entropy. So this is an entropy of a system. Entropy has been derived from the Greek word entropy. The word entropy has been derived from Greek word entropy. Entropy means transformation. This is what its derivation, that has been taken from the Greek word entropy. The concept of entropy was introduced by Clausius in 1837 while studying the application of second law of thermodynamics. When Clausius was studying the application of the first law of the second law of thermodynamics, then he introduced the concept of entropy. It is defined as the ratio of infinitesimal amount of heat to the instantaneous temperature of the system. Instantaneous temperature of the system. So, entropy is equal to heat upon temperature. Heat upon temperature. And it is denoted by S. So, S equal to Q upon T. Now, you can see that the heat and temperature both are the measurable physical quantities. So, entropy is also a measurable physical quantity. Is a measurable physical quantity. So now you can see that its unit, that is now your joule per Kelvin. This is not temperature, so joule per Kelvin. And it can be also, if it is taken now, this kilocalorie per Kelvin. This is on in terms of the heat. It's not so much. And now its dimension, this is now your M1 L2 T minus 2 K minus 1. This is the dimensional formula. So entropy is the measure of the degree of disorder. Entropy is the measure of degree of disorder, order, randomness, etc. of the molecules of a system. So larger the disorder, degree of disorder, larger is the entropy of the system. Larger the degree of disorder, of the molecules larger is entropy of the system. So this entropy is the energy which is not available to do work. तो एनर्जी जो वर्क करने के लिए अवेलेबल नहीं होती है वही डिसऑर्डर इसमें पैदा करती है. Now in case of reversible cycle, in reversible process, entropy equal to constant. It means what? That this integration dq upon t, this is equal to 0, or integration ds, this is equal to 0, or s equal to constant. Since in reversible cycle the temperature remains constant, so this entropy is constant. This is the change in entropy is equal to 0. So the S is equal to a constant. In irreversible cycle, in irreversible process, now this integration dq upon t is not equal to 0. So S is not equal to constant. So in irreversible cycle the entropy increases. Entropy increases in irreversible process. In nature all the processes are irreversible, so the entropy of the nature increases. So this is why that disorder of the molecules in the of the nature is not constant, but it is increasing. The entropy of nature the entropy of environment or nature is increasing because natural processes are irreversible. So the entropy of the nature is not constant, but it is always increasing. Change in entropy. Now this ds equal to dq upon t, or this delta q is equal to TDS. Using first law of thermodynamics, delta Q is equal to du plus PdV. So in place of delta Q we can write down this TDS, or du is equal to delta Q minus PdV. So this du is equal to TDS minus PdV. Thus the change in entropy is the measure of the internal energy of the system. This entropy is the measure of internal energy of system. So you can see that larger the entropy, larger is the internal energy. So there is more chaos or more randomness of the molecules. Now if we have the phase transition, let's suppose we are having this solid, this converts to liquid, liquid converts to gas. When this happens, then the randomness increases, so the entropy increases. Entropy increases. But when reverse takes place, suppose this is now your gas, this converts into the liquid, and liquid converts into solid. When this happens, then the entropy decreases. Entropy decreases. So as we go from solid state to the gas state or the vapor state, there is more entropy. So the randomness of the molecules increases. Now this entropy is also related with the third law of thermodynamics. Thermodynamics entropy of a perfect crystal is constant. So S equal to constant. At absolute zero temperature. So this S equal to zero. So this is what about the entropy that I told you. Sometimes the question is asked that what is the entropy, what is the unit of entropy, what is the dimension of entropy, and what is the physical meaning of entropy. These are the very small questions, or the multiple choice questions are asked in the question paper. So this is about the entropy. So thank you very much.